Hello, welcome back to Math 7 with Mr. Passon. Today we are talking about Unit 7, Lesson 7, Similarity and Scale Drawings. Alright, let's go ahead and change the view of this so we can see what's going on here. Now, we need to talk about what similarity means. And we say two figures are similar if they are the same shape but not the same size. So we could have a larger version or a smaller version, and we're going to talk about that as the scale factor. The corresponding angle measures are congruent or equivalent. Alright, so the angles will measure the same in the small drawing and the large drawing. The corresponding side lengths will be proportional. That's a word that should be coming back from earlier in the year. So if we doubled the side length on one side, we'd have to double another side for it to match. Alright, let's take a look at these images down here. And we're going to see if we can identify the corresponding ones. So, a pentagon, EFGHI, is similar to pentagon RSTUV. Label each of the corresponding angles. So, E and R are a corresponding pair. This angle E is the same as this angle R. We noticed if we rotated the pentagram or pentagon and then made it larger, they would line up exactly. F corresponds to S. So it's angle F and S. Then we've got G and T. Then we've got H and U. And since I'm running out of space, I'm going to go to the next one. And then we've got I and V. Okay, so those are our corresponding angles. Let's look at the next one. Parallelogram JKLM is similar to parallelogram WXYZ. Determine which line segments correspond to one another. So we've got line segment KL. Well, that's going to be the same as XY, or similar to, or corresponds to, because that's actually the word they use. Alright, LM is going to correspond to YZ. And there's a little abbreviation for corresponds to. Alright, we've got MJ corresponds to ZW. And JK corresponds to, oh, those are CORR. I got all those wrong. WX. Alright. That was right above me. I should have just read it to spell it. Alright, so if I made this side half as big, I might get this side, but then I would also have to make this side half as big to get this side. That ratio is always the same. Alright, now, a new thing, because remember it was similarity and scale drawings, the scale factor is always defined as, the scale factor is the ratio corresponding of corresponding sides in a figure. It's always the new over the original. If the scale factor is greater than 1, and let me go ahead and, should have been here, should also be larger so it fits. Make this one larger. Come on, there we are. Maybe move it down a bit. So if the scale factor is greater than 1, we call it an enlargement. Okay. So if we make it bigger, going from like this to this, that's an enlargement. If the scale factor is less than 1, we call that a reduction. Okay, so when we make it smaller, we call that a reduction. Alright, and again, I'm going to move these out of the way so it's a little bit easier to see the word, so those borders aren't getting in the way. Okay, so what we need to know is for something to be similar, the scale factor must always be the same for all sides. Okay, now we're going to look at an enlargement here. The photo below is being enlarged to form a 16 by 20 inch print. What is the scale factor being used? So let's go ahead and remember that our scale factor is what divided by what. Alright, remember it is new divided by old. Now our short side before was, our new short side is 16 divided by our old short side is 4. Our scale factor is, go ahead and do that division. What is the scale factor? Good, it's 4. Again, we want to check the long side because it's only similar if both scale factors are the same. So we're going to take our new, which is 20, divided by our old, which is 5, and we still get 4. Right? So our scale factor is 4. Now we can also do a reduction. A map is being reduced to form a pocket-sized version. What is the scale factor being used to reduce the map? So this is the new one, and this is the old one. So remember, our calculation is always new divided by old. So our new is 6 divided by our old is 24. That's going to be a fraction or a decimal. Okay, so you can either say the scale factor is 1/4 or the scale factor is 0.25. Normally we use fractions when dealing with scale factor, but occasionally someone might use the decimal, and decimals are actually kind of handy when we're doing something called a unit conversion. So we can use either, but in this case I'll probably stick with 1/4, and just know that you can use the decimal or the fraction. Alright, let's go ahead and look again at the next examples. Oh, went too far. So a scale drawing is when we take a shape and we represent it with a different one of a similar size. So a two-dimensional or three-dimensional object can be represented by a scale drawing or a scale model. Okay, now think of examples. Here we could have like diagram of a cell. That's where we have a huge enlargement because a cell is very small and we can't see the pieces of it. Or we could have like a model plane. And that's an example where if you make the model plane, it looks like the big one, only smaller. Alright? Now, let's go ahead and look here. So, use the scale factor to enlarge or reduce the triangle below. So, if this is the original, right, and we want a scale factor of 3, so the new one is going to be bigger. Side AB, it's going to be 3 times as big. 5 times 3 is 15. Alright. Then BC, 13 times 3 is going to be 39. And 12 times 3 is 36. Now we could put the units in there. In fact, we probably should, because it is the scale factor and these are actual measurements. Now, if the scale factor is 1.5, that means our new image is 1.5 times bigger. Alright, so we need to multiply 5 times 1.5. And then let's look at BC, that's 13 times 1.5. Alright. Make that just a bit too big. I'm just going to make all that text smaller so the units fit in there as well. So, centimeters. And last one, again, we need to take 12 times 1.5. So that is going to be 18. Now, for this one, we need to figure out the scale factor. So we can take the new divided by the old. So we've got 9 divided by 12. Well, 9 divided by 12, and ooh, we probably need to write in that scale factor. So let me go ahead and grab a text box and put it in here. So our new is 9 divided by 12, which is, both of those are divisible by 3. That's 3/4 or 0.75. All right? So we need to figure out 5 times 3/4 is 3.75. Good, that one worked. Then we need to do 13 times 3/4. All right? So I'm going to do that real quick. 13 times 3 is 39, and we have 39 divided by 4. That goes in 6 times. Oh, let me go ahead and just actually write that out. So I'm going to draw my division bar here. So I've got 39, divided by 4. It goes in 9 times, because 9 times 4 is 36. And with a remainder of 3, so 9 3/4, or 9.75 if we go ahead and do the work. Put in the decimal. So we get 9.75 centimeters. And again, looks like I needed to make that smaller. I'm just not going to put in the centimeters on that one. Excuse me. Alright, now let me clear that out and we'll look at the next one. Answer the questions below. Be sure to show all of your work. Triangle PQR is shown below. Its original lengths are multiplied by 2.5. What are the lengths of P prime, Q prime, R prime? So we're increasing everything. Alright, so it's multiplied by 2.5. So we got 15 times 2.5. And that is going to be one side. Then we've got 8 times 2.5. And then we've got 17 times 2.5. Alright? So let's go ahead and figure out what each one of these are. So this one is 37.5. Note that I can do this kind of sneakily because I can do 15 times 2 and then add another half. So 15 times 2 is 30, and then half of 15 is 7.5, so I get 37.5. Here I get 16 plus 4, so that's going to be 20. Here I get 34 plus, what's half 17? That is 8, so 42.5, 8.5. All right. Now, if I got any of these wrong, in fact, I should probably check. So I'm going to pause here and check and see if I did any of that math wrong. Okay, I did all of that right. Excellent. And all these would be centimeters. Let's look at this one. So rectangle ABCD has been enlarged to form triangle A prime, B prime, C prime, D prime. Notice the orientation has been flipped. So here is the short side, here is the long side, here is the short side, here's the long side. But AB is the short side, A prime, B prime is a short side. So what is the scale factor? Remember, this is our new one, so our scale factor is what divided by what. Go ahead and answer that. Alright, our formula is new divided by old. So we've got, in our case, 18.6, which is our long side, divided by 6.2. Or, and we want to check both of them just to make sure they actually did it right, let's take 7.5 divided by 2.5. Now, both of those, go ahead and grab a calculator, do them yourself, but you could probably also figure it out. And I get that they're both 3. So the scale factor, that's not a nail. All right. The two parallelograms below are similar. So it tells us the ratio that they are similar, and we need to find the missing length. Well, we can set up our proportion equation. Remember, this is our new. Now, I am always going to take whatever side is my variable on it and make that on top. All right? So I can either say x over 6 is the same as 15 over 9, or I could say 6 over 9 is the same as x over 15. All right? So I'm going to take short side new over short side old. Sorry, that's the long side. The long side new over the long side old. So x divided by 15 is the same as short side new divided by short side old. But this over here I can simplify. So I've got x divided by 15 equals 2/3. That's not a divided by. X divided by 15 equals 2/3. How do I get rid of a divide by 15? Well, I multiply both sides by 15. And that gives me x equals whatever 15 times 2/3 is, which equals 10. All right? So this missing side, x is 10, and our units are inches. Okay, let's go ahead and do this again for number 9. All right, Susie walks 1.5 miles to school, where she looks at the map and shows the scale to be 1 centimeter is 0.5 miles. What is the distance between Susie's house and her school on the map? All right, so on the map, we have a known distance, the little marker on the scale, and an unknown distance, x. So x divided by 1 centimeter is going to have to equal, and this is going to be in centimeters, is going to have to equal how far she traveled in the world divided by however far that was on the map, which was however far 1 centimeter is on the map. So that's 0.5 miles. So we have miles and miles. Now notice, just like with numbers, if we have the same unit on top and bottom, they actually cancel out. So these cancel out, and we're just left with a pure number. So if we know what 1.5 divided by 0.5 is, that's going to let us know what x is. All right? So 1.5 divided by 0.5 is 3. So our x is 3 centimeters. So on the map, the distance between the school and Susie's home is 3 centimeters. All right, summarize what you learned today. We're going to take some examples. We're going to be working in class on the assignment, and I will talk to you then. Bye.